Okay, we're on question 13 and 14. It says graph the polygon's image after a rotation of the given number of degrees counterclockwise about the origin. So if you want to write these down on your note card, that would be a good idea. So if we rotate, let's say 90 degrees counterclockwise, the rule is we get negative y comma x. Okay. If you rotate 180 degrees, either direction, works for both ways, we get negative x comma negative y. And then if we rotate 90 degrees clockwise, we get y comma negative x. Okay, so if you want to write those down on your note card, that should help. And there's a way of going about it that you can figure it out if you don't have those, but this is just a little bit easier. So the first one wants us to go 270 degrees counterclockwise. And what we need to realize here is, if, let's say I have a point here, if I go 270 degrees counterclockwise, that's the same thing as going 90 degrees clockwise. Okay, so we'll use this one, where the rule is, okay, so let's try it out. C is located at 0, 4. This is our x value, this is our y. So our new point, C prime, should be located at 4, comma, negative 0, which is just 0. Okay, so 1, 2, 3, 4. Here's our C prime. And then if we look at A prime, we should be getting our y is 1 and our x is 2, so we'll make it negative 2. Let's get 1, comma, negative 2. There's our A prime. Okay, now finally let's do B. So our B prime should be 1, comma, positive 3, not negative 3. So we have 1, comma, positive 3. There's our B prime. Alright, let's check it out. Let's connect the dots. There we go. Okay, does this look like it's been rotated 270 degrees counterclockwise? Yeah, it looks like it has been. Good, this looks good. Yeah, it looks like a 270 degrees counterclockwise rotation. Now 180 degrees, let's look at our rule. Negative x, comma, negative y. So our rule is negative x, comma, negative y. Alright, so our point D is negative 3, comma, 2. So if we're doing a 180 degree rotation, D prime should be located at 3, comma, negative 2. We're just changing the signs. F prime would be at negative 1, negative 1. G prime would be located at -1, 1, and E prime will be located at 3, 3. Okay, plot those, check it out, make sure it looks like a 180-degree counterclockwise rotation. Alright, let's get to this problem here. Mr. Lincoln asked his students to find the line of reflection that maps triangle XYZ to triangle X prime, Y prime, Z prime. Bill and Ted got into an argument over the correct answer. Bill thinks the line of reflection is Y equals 2, while Ted argues the line of reflection is X equals 2. Which one do you think is correct? You need to remember that the line Y equals 2, what is going on? Y equals 2 is a horizontal line, so that looks like this. Does it look like a reflection over that line? No, it does not, but it does look like it's a reflection over the line X equals 2. Okay, because it looks like it's reflecting over a vertical line right in the middle. 1 unit, 1 unit. 2 units, 2 units. 1, 2, 3, 4 units. 1, 2, 3, 4 units. Good. Looks good. So, Ted's right. Good job, Ted. Mr. Lincoln asked his students a new question. Quadrilateral QRST was rotated about the origin by some degree measure. How many degrees was it rotated? This time Mike and Sully couldn't agree on the answer. Mike thought the quadrilateral had been rotated 270 degrees, but Sully says the quadrilateral was only rotated 90 degrees. Who is correct? So, if you think about it, let's see, how do we get from here to the origin? We go to the left 4 and down 6. So we must go to the right 6. No. Is that accurate? Go down 4 and to the right 6. Okay. Yeah, I was right. To the right 6 and down 4. Okay. This is the visual way of doing the rotations. And this does look like a 90-degree rotation. But if you went 270 degrees the opposite direction, as we previously talked about, it's the same exact thing. So you could check if you wanted to. Q is located at 3, -9. And so let's look at a 270-degree rotation counterclockwise, or clockwise. It would be the same as a 90-degree counterclockwise rotation, which is -y, x. Counterclockwise. That would actually be clockwise. So I'll write the other rule. Y, -x. So if we took Q and we rotated it 90 degrees counterclockwise, it would look like this about the origin. 90 degrees clockwise. But if we went 270 degrees counterclockwise, it would end up here. It's the same thing either way. Okay, so who is correct? Technically they're both wrong because they don't recognize that a 90 degrees counterclockwise rotation is the same as a 270-degree clockwise rotation. Transform rectangle JKLM so it sits in the shaded rectangle in quadrant 3. Use only rigid motion transformations. Describe how many different sequences of transformations you can make. So it sits in the shaded region. Ah, I see. Okay, so we can do so many different things. The first thing I see automatically is a reflection over the line y equals negative x. Though we didn't really go over this too much, if we did do that, you would see these all be the same distance, like this, from that line. And it would either sit inside the shaded region or be very close to sitting in the region, in which case we could just translate it. Another thing that could be done is a rotation 180 degrees, so that would be like this. And if we were able to do that, we'd rotate 180 degrees and maybe we'd have to translate it. Another thing you could do is, let's say, a reflection over the x-axis, which would put you down here. Oh, like this, and then rotate it 90 degrees clockwise, and then maybe translate it. So there's really infinite ways you can do this problem. Pick a specific way that you would do it. Ramon states that there are 3 ways to transform QRST to place its image in the shaded region in quadrant 2. So here's our shaded region. Let's zoom in. So it says translate QRST 3 units up and then 15 units to the left. Oh goodness, these go in 2, so this would be 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So it'd end up here. This would end up here. 1, 2, 3.5. So this would be 13 units up, and then 15 units to the left. We need to go 2, 4, 6, 8, 10, 12, 14, 15 would be right there. And then we'd end up right here. Okay, yeah, it looks like after this transformation we would end up within the boundary we'd need, so let's erase this. Okay. Now let's try a reflection over QRST, QRST over the x-axis, then again over the y-axis. So it looks like this is 3 units away from the x-axis. So let's go 3 units up. There's our t prime. Q is 1, 2, 3, 4. So 10 units. So we'll go 10 units up. It's 10 right here. And then since this is a rectangle, we can really just make this very simple. Okay, so here's a reflection over the x-axis. If we reflected over the y-axis, we get this as 4 units. So 4 units would put us here. Same thing here. This is 1, 2, 3, 4, 5, 6. So 12 units. 12 units over. Looks like we're barely inside. So this one works. I only have 20 seconds, so we'll end right there. Try that last one on your own.